Hi, in this video we're going to look at the topic of bearings. Now, this is a topic that can appear both on the higher and foundation papers, so I'm going to cover two different things. I'm going to cover the basics and fundamentals, which will appear on the foundation paper. I'm then going to do one question as an example that's a higher topic, and leave an example for you to do at the end that's also a higher topic. So there's plenty for everybody in this video. What we're actually going to look at is looking at measuring a bearing, so that's from one point to another point, look at drawing a bearing, and be able to calculate a bearing given some information, and that information might be something that's on a foundation paper, so you might be given some angles, and you've got to work out another angle fact, or it might be a length and you've got to do some kind of scale measurement maybe, or it might be something a little bit more complicated where you've got to use Pythagoras or trigonometry to work out a length or an angle. So in this example then, I've shown a little picture here, and the picture's got a north arrow here. This is really important. We're always going to be working, whenever we're doing bearings, from north. And I've got four places: Dodd, Whiteside, Grisdale Pike and Lord Seat. Now what actually we're going to be doing is using our protractor to be able to pick an angle, and we're going to measure from north down to the place that we're going to. So if we were doing, for example, Whiteside from Dodd. So let's have a look here. So let's say we were doing Whiteside, and then the key word here is from. We're going to do from Dodd. Now if it's from a place, that's where you're going to put your protractor. So we've got our protractor in. You'll notice that I've lined it up, so I've got 0 pointing upwards. So I've got 0 up here. This is my north line. Now what you would actually do is draw a line in going north from Dodd. I'm not going to do it on here because it gets confusing, but if I were to do that, then we can see that we would have a line going straight up from Dodd. Okay, now what I'm also going to then do is look at measuring around. Now what I'm going to do is draw north in. So number one, draw north in from the place that it says from. Okay, I'm then going to measure clockwise. So 0 is at north. Here's 0 up here, and that's my north line. I'm going to measure around clockwise until I get to Whiteside. Now I can see on here that Whiteside is at 170 degrees, and actually that's my bearing. Whiteside from Dodd equals 170 degrees. Okay, it's as simple as that. Now if we were doing another point, let's say we were going from Dodd to Lord's Seat. You can see Lord's Seat's up here. Again, what we would do is draw a line going up from Dodd to Lord's Seat. And again, this time we can see we're measuring around clockwise from north. I've not had to move my protractor at all. We can see this is 50 degrees. So what you might be thinking is that Lord's Seat from Dodd is 50 degrees, but actually we write a bearing as 3 digits, so we'd say 050 degrees. Okay, so the key things that we've got so far are when it says from, so whenever the question says from, and we'll see some questions in a minute, that's where we draw our north line in, so a line, straight line going up north. We're going to measure using our protractor from north, and we're going to measure around clockwise, so we need to make sure that 0 here on our protractor is pointing at north. We're then going to measure around until we come to the place that we're looking for. So it's always worthwhile drawing lines in to make sure we do that. So actually draw your lines in to ensure that that works properly. Okay, so let's just say if we were to draw a straight line in from Dodd going north, we can see that this angle around here is 50 degrees, and actually that means that the bearing would be 050. Okay, Now we can use various angle facts to work out other things because we know information like if this is north, this would be east, and we know that that's 90 degrees. We know this is south, again 90 degrees or 180 degrees from north. West again is another 90 degrees, and we know it's 360 all the way round. So this would be 90 degrees or 090 as a bearing, 180 degrees as a bearing, 270 degrees as a bearing. So if you've got a place up here, let's say, and we're going to draw a line to it, obviously with your 180 degree compass, we're not going to be able to protractor, we're not going to be able to measure all the way round that far because we won't have to start at north. We're going to come all the way round. Now what it might be easier to do is to think, well, I know where it is from 180, I'll just measure this part of the angle just around here. If I were just measuring that bit and adding it onto 180, that works perfectly well as well. Okay, so there's all kinds of things that you might need to just take care of in terms of measuring with your protractor, but fundamentally there are three things to remember, and again we'll do this at the revision notes at the end. So start at north, measure clockwise, and write your number as 3 digits. So 3 digits for your bearing. Okay, let's have a look at another example. Okay. This is an exam question. It says, the scale drawing shows the position of two towns, Bury St Edmunds and Ipswich. Measure the bearing of Ipswich from Bury St Edmunds. Okay, so what we need to do is take our protractor. We're going to put it on in the right place, which is here, and we're going to measure round. Now, remembering we're measuring from north and we're measuring round clockwise. So, put it on my north line. I've made sure I've got 0 up here at north. Measure round clockwise, we can see here is the value, which is 75 degrees. That's not the bearing though. The bearing we have to write down as 3 digits. So measuring the bearing of Ipswich from Bury St Edmunds is 075 degrees. That gets us the full marks. Okay, now a further question on one of these might say something along the lines of move this out of the way, might say something along the lines of measure the actual distance between Bury St Edmunds and Ipswich. And again, we've been given a scale here, 1 centimetre to 4 kilometres. So you'd simply use your ruler and scale it up by 4, so multiplying it by 4. So you could actually physically measure that and times it up by 4. The key things that you're looking for in these sorts of foundation questions are the word measure. If it said measure the bearing, we're using our protractor, compass, ruler, whichever, protractors and rulers, to make sure that we can actually physically measure them. If it said calculate, then we're going to have to do some maths in terms of using our angle facts. And here is an example of one of those where we're going to have to do some maths. Now this is a higher GCSE question, so if you're a foundation candidate, don't worry about seeing these ones. If you are higher, then obviously we're going to go through this example now. So it says ship A is 10 kilometres due north of a lighthouse L. So we can start picking out these things. Here's my ship A, and it's due north from L. Ship B is over here, and that's 12 kilometres from A, and we can see that information, and is on a bearing of 056 degrees from the lighthouse L. So here it is coming up here, and again it's been measured from north, coming around clockwise. Here's the bearing. What it's asking for is the bearing of B from A. So what it wants to know is calculate the bearing of B, so that's the boat here, from A. Now remember, when it says from, that's where we would measure our north line. Now we've already got a north here, so actually what it's asking for is just this angle here, but written as a bearing. Okay, now it doesn't say measure, it actually says calculate. So because it says calculate, we're going to have to do some maths. What maths are we going to do? Well, we've got a triangle and we've got some information. Now, when we've got a triangle and some information, we've actually got an angle, we need to be thinking about trigonometry. Have we got a right angle? No, we haven't. So we can't use our normal SOHCAHTOA trigonometry. We're going to have to use either the sine rule or the cosine rule. Now, what I would be tempted to do here is to use the sine rule, because I've got two sides and I've got a pair of opposing information. I've got a side and I've also got an angle. Now, I've also got another side, and that means I would be able to work out what this angle is here. And no, it doesn't ask for that in the question, but if I've got one angle and then I've got another angle, I can then use my laws of triangles to be able to work out what this angle is and therefore what that angle is up there. So there's a lot to do here, but we should be able to work through it fairly neatly if we make a start. So if we're finding an angle, we're going to use the sine rule. The sine rule is given to you, remember, and it says sine A over little a equals sine B over little b. Okay, so let's put some information in. I'm going to say that sine 56 over 12 equals, well, this is the angle I'm trying to work out. I'm trying to work out sine B over 10. Rearrange this and I get that sine B equals 10 multiplied by sine 56 over 12, and B therefore would be sine to the minus 1 of this information, 10 times sine 56 over 12. I'll do that on my calculator and I get 43.7 degrees. So the angle B that we were working out up here is 43.7 degrees. Okay, I can now use my angle facts to show that 180, so I'm going to do 180 minus 56 minus 43.7. That's going to tell me what the angle is up here. Okay, and that's 80.3. Oops, 80.3. And finally, that means I'll be able to work out what the bearing is of this part here. So again, if I do 180 minus 80.3, I get 99.7. So 99.7 degrees. Now, if I'm going to write that as a bearing, then I need to make sure that I do it properly. That's 3 digits. So the bearing would be as follows. So it's the bearing of B from A is equal to 099.7 degrees. Okay, and we've done. So the question may have gone on later on to ask us to round that up to the nearest degree. If we wanted to round it, we could say it's 100 degrees as a bearing. Either way, I think we just need to be careful of what the question is asking for, but 99.7 degrees is exactly right. So here's your go. This is what I'd like you to have a go at if you're foundation, or if you're higher and you want to have a go at this sort of question, that's fine. So what's the bearing of Dieppe from New Haven? You might have to pause the video. In fact, you'll definitely have to pause the video. You might need to get your tools out, so your protractor, stick it on your screen, see if you can work it out. I'll pause the video and show you the answer in a second. Okay, so you need to get your protractor. Oops, I'm just going to go back. Let's just rub that bit out. Okay, so you need to get your protractor. You need to make sure you've drawn a north line. I haven't, but I'm just going to have a bit of a guess at it. And so there we go. I'm thinking this is 145 degrees. So 145 degrees. In an exam, you're always given 1 degree either way, in case you don't get your north line exactly right. But that's what you're looking for. 145 degrees, and I've made sure I've put my protractor pointing at north where 0 is on my protractor. I've gone clockwise round and I've measured off the right scale. So remembering I'm measuring round, coming this way, which means I'm always reading off on the outside scale. Okay. If you are a higher candidate, then you can have a go at this one. This one says 2 Coast Guard Station P and Q are 32 kilometres apart, and we can see that information on here. Q is due south of P, so that means that this line is a perfect line going north. Boat B is on a bearing of 145 degrees from P. So here it is, it's going 145 degrees down here, and 040 degrees from Q. We've been asked to work out the distance QB here. Okay, so have a think about how you're going to do it. If you're not sure on these types of trigonometry type questions, you might want to go back and check a previous video that I've done all about sine and cosine rule. Otherwise, pause the video, have a go at it. Okay, so let's have a think about what information we've been given then. We're trying to work out this length here. Okay, so I'm going to call it X. What information do we have? Well, we've got a length and we've got an angle. We've also got another angle here, which we could write in as 35 degrees, because we know that. We know that angles on a straight line add up to 180. Oh, that also means that I know what this angle here is, because I have angles in a triangle. And again, 40 and 35 is 75, so this is going to be 105 degrees here. That means I've got enough information to use the sine rule. So I can then say that we've got, I'm trying to find a side, so A over sine A equals B over sine B. If I'm labelling these things up properly, I'm going to say that my X is little a, and this angle here, 35, is going to be my big A. And I've also got this can be my little b, and this can be big B over here. Okay, let's start putting some information in there. So I've got X over sine 35 equals 32 over sine 105. Rearrange it to work out X. X equals 32 over sine 105 multiplied by sine 35. I'm going to do this on my calculator to work out what X is, and the number that comes out is 19.0019, or 19. Now, just thinking about what values we've got, these are all in kilometres, so this is going to be 19 kilometres. Okay, hopefully you got that right. That I've done so far, we've had revision card notes at the end. The key things that I would say here are as follows. So measure from north. So you're going to end up with something, the north line. This point here is when the question says from. So this is where you're going to go from. You're then going to draw another line in to the point that it says 2. You're going to measure around clockwise, like this. You're going to work out what the angle is. So this is 0 degrees up here. You're going to work out the angle, and you're going to write it down as 3 digits. So let's say this was 55 degrees. The bearing would be 055 degrees. Okay, so if it says measure, we're going to be using our ruler and our protractor. If it says calculate, then you're going to be looking for different triangle facts, internal or external angles, angles on straight lines, Pythagoras, or even trigonometry if you're a higher candidate. Okay, hopefully you found this video useful. Keep checking out the YouTube channel for other videos that are coming all the time. Follow the @TupToMaths or at Mr_G_Walton for regular updates. And if you want to ask any questions, please do so. Good luck with your exams. See you soon. Bye.